The next item we need to discuss is finding your zeros from your graphing calculator. And there actually are multiple ways to do this. There is an app called PLYSMLT that for those of you with a TI-84, even if the TI-84 is quite old, you probably do have the PLYSMLT app. You can also use your calculator's graphing screen. So those are the two things that we're going to discuss right now. In terms of the PLYSMLT app, look, if you don't have a TI-84 graphing calculator, obviously you're not going to be able to use the PLYSMLT app. Some other calculators will do this type of calculation in various ways. Like for instance, the TI Inspire does have a built-in function that can find the roots of a polynomial. And again, there's probably other calculators out there that have this function or have an app like this. If you don't have a TI-84, I am not telling you to rush out and get a TI-84. It's not absolutely necessary that you do that. The benefit of having PLYSMLT on your calculator is not so great that you definitely should get a TI-84 calculator just for this test. It is a nice thing to have. It is not necessary to have. So anyway, how does the PLYSMLT app work? Let's run through this. We are going to use the TI-84 plus CE, and then I'll run through this on the old TI-84 plus. It'll be a silver edition, but should be representative of what all of the old TI-84s look like. So we go to apps. The PLYSMLT app is in apps, and we can see it right here as number 9. Various calculators will have various applications on them. So if you don't see PLYSMLT at number 9 at the bottom of your list here, then just scroll through your apps and see if it's there. I could either right now hit number 9. I do, however, want to make the point that if we want to go right to the P apps, to the apps that begin with P, we can always hit alpha and then the 8 key, and that takes us to the P app. So it's just another way to get to the app that you want. So I'm going to hit number 9 now, or I could also go down, highlight number 9, and hit enter. So this app, the PLYSMLT app, does two major things. Numbers 1 and 2, polynomial root finder, that's the one we're going to want here, and a simultaneous equation solver. We talk about that in a different section of the manual. So number 1, polynomial root finder. For those of you that have been watching these videos for the quadratic section, you know that everything that we have been doing up until this point has been finding roots or zeros. Roots and zeros are synonymous of a type of polynomial function, namely quadratic functions. Quadratics are a type of polynomial. So what we want to do is we want to find the roots of a polynomial, which is why we're using the polynomial root finder. So we hit number 1. Order is the same as degree, and you will recall at the very beginning of this section we said that the degree of a quadratic function is 2. I do always want our second row here to reflect that we are in complex mode. So if yours says real mode, you need to change yours into complex mode. The last 4 rows should all look like this. If they don't look like this, set them to look like mine. So decimal, normal, float, and degree. It doesn't really matter what those last 4 rows are, but so that we're all on the same page, let's make them all look the same. We are then going to hit the next button, which is the graph button. By the way, all of this stuff is diagrammed here in the manual. I'm going to hit the graph button, and what I'm going to do is, you can see the highlighted box right now is in my A position, right? The position right before the quadratic x term. So let's type in one of the quadratics that we saw on a previous page. We're going to do 1 for A. So 1's already in there. I could just hit enter, but I'm going to hit 1 and then enter. The cursor then moves to the plus sign here. I'm just going to go to the right, and I'm going to enter this 6 here. And then for this last position, I'm going to enter a 12 and hit enter. So what I now do is I hit the solve tab, which is again the graph key. I hit solve, and what pops up are my 2 roots. You can see I'm getting -3 plus some imaginary number and -3 minus some imaginary number. By the way, this quadratic that we used here is from the previous page. It's actually this quadratic function h here, and you will recall that this was one of those parabolas that had a negative discriminant and therefore had imaginary or complex roots and therefore did not hit the axis at all, our imaginary or complex roots are right here, -3 plus I root 3, -3 minus I root 3 in the PLYSMLT app. That's exactly what we're getting right here. -3, this 1.73 is actually root 3, and then the I, and -3 minus 1.73, and then the I. So if I were to do, for instance, let's do g of x. Let's go back to coefficients, which is the zoom button. So we're going to hit the zoom button. Let's enter in a 2, a -16, and a 32. So a 2. I could either do -16 here, or I can just enter in a -16 and enter. And then over here to the right, I'm going to do not negative, I'm going to do 32 and enter. And then when I hit solve, I get that double root. I get that one real or double root of 4. So that's how we can use, if we are on the calculator section, obviously we need to be on the calculator section in order to use the PLYSMLT app. If we are on the calculator section and we need to find our roots or our zeros or our x-intercepts, we can use this app. By the way, although it's unlikely that you would need to on the SAT, this app, the PLYSMLT app, actually can find the zeros for higher degree polynomials. In other words, the app can handle more than quadratics. If we go back to mode, which is the window button, this mode tab corresponds to the window button. Remember, in this first row, we can select the order. You can see that this app can actually find zeros all the way from a linear function, there's quadratic, there's cubic, quartic, all the way up to a 10th degree polynomial function. So if I change my order to 3 and then hit enter, so now I'm finding the roots of a cubic function. You will see when I hit the next tab, which is the graph button, that I now have the option to enter a coefficient in front of my cube term, in front of my quadratic term, my linear term, my constant term. So I'll just do something random here. So let's do 2 and then -3 and then let's do -6 there, and then let's do 10 there, and we're going to hit graph, which is solve, and you can see that this cubic has a real zero at -1.77. If I go down and then arrow to the right, so there's one imaginary root and there is the other imaginary root. Imaginary roots, some of you may know, always come in conjugate pairs. For those of you who are familiar with complex numbers, you know what conjugates, complex conjugates are. So those are the conjugate imaginary roots. By the way, if I hit fraction to decimal here, yeah, nothing happens. These are not rational roots. So again, by going to the mode screen, you can find the zeros of any degree from 1 to 10, any degree polynomial from 1 to 10. On the SAT, highly unlikely you would need to use anything other than the quadratic, the order 2, but occasionally you may have to find the roots of a cubic, and this app will do that for you. Now, in the other calculator, in the older TI-84, let me get into that calculator. The layout here will be slightly different. We're going to go to apps. We are going to go alpha and then the 8 button, which is the P key. We are going to do PLYSMLT, which is right there. So I arrow down until PLYSMLT is highlighted. I hit enter. The intro screen, the title screen, is telling me to press any key. I go to polynomial root finder as I did before. I'm going to change my order back to 2 because remember, a quadratic has an order or degree of 2. I am on A plus BI. All of this stuff can stay the same. I'm going to hit the graph button, which is next. And in this case, I'm going to go back to this quadratic here. I'm going to enter a 1 and a 6 and a 12. So you can see the setup here is a little bit different. They're asking for A2, which is the coefficient in front of x squared. That's normally what would be in your A, just your regular old A position. In your B position is A sub 1. That's the coefficient in front of the linear x term. And then A sub 0 is your constant. That's your C term. So again, this is your A, your B, and your C term. I have them all in there. Now when I hit solve here, I get -3 plus, and you can see there's these 3 little dots at the end, this ellipsis. So what I need to do to see what's at the end there is I just need to arrow right. And once I do, I can see that my 0 there is imaginary. And of course, I can do that for the second 0 too by arrowing down so that the cursor is now highlighting the second equal sign. And again, if I scroll to the right, I can see that I. Last thing I will tell you, you can switch. This is true of both the newer calculator and older calculator. You can switch between fractions and decimals by hitting this button right here. It's not going to help us in this case because we don't have a fraction, we have a whole number. But if we were to hit the graph key, let's say this said 3 divided by 2, if we were to hit that graph key, it would change to 1.5. So this graph key would toggle between our fractional and our decimal answer. So again, if you have a TI-84, yeah, it's a nice benefit to have the Polynomial Root Finder app on your TI-84. If you don't have the TI-84, again, I'm not telling you to rush out and get one unless you were planning to do that already. To get out of the app, you can keep hitting second and mode, which is your quit button. You can also go to, I'm going to go back into the app so that let me go alpha P. And once we are in there, let me get back into this and next and solve. So let's say I'm here and I want to get out of the app. I can hit the main button, which is my the main tab, which is my y equals button, and then number 6 is quit PLYSML. So I can hit number 6 and I can get out of there. By the way, if you're ever stuck on a screen in your calculator and you just can't figure out how the heck to get out of that screen, you can always turn your calculator off and back on, and usually that will get you unstuck. Now, in terms of using the graphing screen, we can use our graphing screen to help us find zeros in the following way. So what I'm going to do is I'm going to go to y equals. I am going to enter in x squared minus 2x minus 1. Okay, I'm using this quadratic right here. And what I am going to do is I am going to graph that. Now, a quick visual inspection here would tell me that it looks like my zeros are probably about, I don't know, what does that look like? -0.5 and maybe 1.6, 1.7. So just by graphing the function, you'll get some sense of where your zeros are. However, you're going to want a more than some sense of where your zeros are. You're going to want to know exactly where your zeros are. So what we are going to do is as follows. We are going to hit second and then the trace button, and you will notice right above trace you see this calculate, C-A-L-C in blue. So when you hit second and trace, you'll bring up your calculate menu. We want our 0, number 2. So I'm going to hit number 2. Now what I need to do is I need to bound the 0 that I want. You see the calculator is asking me for a left bound. So what that means is I've got to move my cursor to the left of the 0 that I want. So let's say I want the 0 on the right. So if I want the 0 on the right, you can see how my cursor is just to the left of that 0 right now. So I'm going to hit enter. That will be my left bound. You can see this little triangle comes up. Now the calculator is asking me for a right bound. So what I'm going to do is I'm going to go to the right of that 0 and I'm going to hit enter again. So now you can see that this 0 here is captured between my left and my right bound. I have just captured that 0 between two x values, two vertical lines, so that the calculator knows that it is that 0 on the right that I want. The calculator is asking me, do I want the calculator to take a guess? And yes, of course, calculator, I want you to take a guess. So I am going to hit enter. And the calculator is telling me that there is a 0 at 2.414, which actually is 1 plus root 2, which was one of the two zeros of 1 plus root 2 is right here. The quadratic that we used here, function f, which is what we just typed into the calculator, x squared minus 2x minus 1, x squared minus 2x minus 1, and 1 plus root 2 is one of these zeros, and that is what we just produced. That it's actually written right here, that 2.414 is equivalent to 1 plus root 2. So again, we just made the calculator produce one of the zeros using our graphing screen. If we wanted the left 0, we would just have to bound that 0 in the same way that we bounded or captured the right 0, and the calculator would produce a value for this left 0. And one final note when it comes to graphing quadratics with the calculator's graphing screen, remember you do not need a standard form quadratic in order to make the calculator graph the quadratic. A vertex form, a intercept/factored form, a standard form. You can enter any form into your y equals menu and the calculator will graph the quadratic, meaning that you can see the zeros on the graphing screen no matter what form of a quadratic you're dealing with.